Hello everyone, this is Kalpana here. In this video, we are going to see a problem using method of undetermined coefficients. So let's get going. Problem: solve d power 4 minus 2d square plus 1 into y equal to x minus sin x using the method of undetermined coefficients. So we are given a differential equation d power 4 minus 2d square plus 1 into y equal to x minus sin 2x, which is an operator form f of d into y equal to some function of x. Okay, say q of x, right? Now we can write this equation as d power 4y minus 2d square y plus y equal to x minus sin x, right? Or we can write it as y to the power 4 minus 2 y double dash plus y equal to x minus sin x, right? Both the equations are same, isn't it? Now we need to solve this equation and find the general solution to the problem. Okay, coming to the problem, given differential equation d power 4 minus 2d square plus 1 into y equal to x minus sin x, considered as equation number 1, or we can write this as y power 4 minus 2y double dash plus y equal to x minus sin x, right? And the given equation is of the form which is an operator form f of d into y equal to q of x, where f of d equal to d power 4 minus 2d square plus 1 and q of x equal to x minus sin x. Now we need to find we need to find the general solution to this equation, which is given by y equal to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find yc using auxiliary equation. Later we'll find yp with the help of yc and q of x. Okay, fine. Now coming to the auxiliary equation, let's find yc. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d power 4 minus 2d square plus 1, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m power 4 minus 2m square plus 1. Now the auxiliary equation becomes m power 4 minus 2m square plus 1 equal to 0. We need to find roots to this equation. Let's write m power 4 as m square whole square minus 2m square can be written as minus m square plus 1 equal to 0. Now take m square common from the first two terms, you'll get m square times m square minus 1. Now take minus common from the next two terms, you'll get minus of m square minus 1 equal to 0, right? You can write this as m square minus 1. Just take m square minus 1 common from these two terms, you'll get m square minus 1 into m square minus 1. Right? You can write m square minus 1 as m square minus 1 square. Right? You can write this 1 as 1 square simply. This is of a square minus b square form. You can write it as a plus b into a minus b. Likewise, here also you can write it as, you can write a square minus b square as a plus b into a minus b. Right? We have m plus 1 into m plus 1 into m minus 1 into m minus 1 equal to 0. Now we equate each term to 0. When m plus 1 equal to 0, you'll get m equal to minus 1, and when m minus 1 equal to 0, you'll get m equal to 1. Since m plus 1 is repeating twice, so you'll get m equal to minus 1 twice, and when m minus 1 equal to 0, you'll get m equal to 1. Since m minus 1 is repeating twice, so you'll get m equal to 1 twice. Minus 1 is repeating twice and 1 is repeating twice. Okay, these two are real and equal, these two are real and equal. So we know that when two roots say m1 and m2 are real and equal, then yc will be c1 plus c2x into e power x, that is e power that equal root into x, right? Let's utilize this formula to find our complementary function. yc equal to, first we'll write for minus 1, we'll get c1 plus c2x into, we'll write for the equal root minus 1. Now let's write for 1 equal to 1. We have used c1 and c2. Now let's take c3 and c4. c3 plus c4x into e power another equal root 1 into x. Then yc becomes c1 plus c2x into e power minus x plus c3 plus c4x into e power x. Therefore, yc equal to c1 plus c2x into e power minus x plus c3 plus c4x into e power x. We got yc, we need to find yp now. Observe yc and yp. We have yc equal to c1 e power minus x plus c2x e power minus x, c3 e power x plus c4x e power x. And q of x is x minus sin x, right? Now observe the terms of x in yc and in yc and q of x. Here you're having e power x, e power minus x, x e power minus x, e power x, x e power x. Here you're having x sin x. So you don't have any common terms of q of x with yc, right? Therefore, q of x has no common term with yc, right? So therefore yp must contain the linear combination of q of x and all its linearly independent derivatives. Okay, so here in q of x you are having x, right? When q of x is x square, yp will be a naught x square plus a1x plus a2, because derivative of x square is 2x, so you'll get x into some constant, and derivative of x is constant, so instead of writing constant you'll write a2. Okay, likewise when q of x is x, then yp will be a naught x plus a1. Since if q of x is x, then yp contains x and its derivative. If q of x is x, its derivative yp will contain q of x, say x, and its derivative. Its derivative is 1, right? So you're having x with quotient a naught, and instead of 1 you're writing a1. Instead of writing constant you're writing a1. Okay, fine. When q of x is sin x or cos x, yp will be a naught sin x plus a1 cos x. This is a formula. Okay, so it is not that easy to remember the formula all the time. So how? You just write, you can pick yp by finding derivatives of q of x with the help of q of x. Let's see that process. Okay, you can just blindly write this formula, but it is not easy to remember. Okay, you may do some error. So let's find yp with the help of q of x. We have q of x equal to x minus sin x, right? Now I'm trying for x. When q of x equal to x, yp will contain its x, that is the term of q of x, and its derivative. Derivative of x is 1. Likewise, when q of x is sin x, yp will contain sin x and its derivative. Derivative of sin x is cos x, right? Now observe x, 1. Forget about the signs and coefficients if any. You're having x, 1. Consider x, 1, sin x and cos x. Okay. So you can find again a derivative of this. Okay. The derivative of sin x is cos x. Derivative of cos x is minus sin x. So from sin x, you'll get either sin x or cos x, not either sin x. Both sin x and cos x. You'll get cos x and sin x and nothing else. Right? Now, what we did, we are having q of x. We are finding the q of x and its derivative. Here I wrote q of x and its derivative, q of x and its derivative, or term of q of x and its derivative. We can just again find derivative of sin x plus cos x if you are not that sure. Now observe the terms x, 1, sin x, cos x, sin x. Okay, irrespective of signs and coefficients. Now yp will contain the terms q of x and all its linearly independent derivatives, right? So here we have x, a constant. See, here we are having the term of q of x, okay? Fine. And sin x or cos x, right? With the help of 1, 2, 3, 4, we'll write yp. Okay, yp equal to, we have x, right? X with the quotient a. Instead of writing constant, we'll write quotient b, plus sin x with quotient some c, plus cos x with some quotient d. Okay, ax plus b for x, sin x, c sin x plus dx for sin x. This is a yp using trial method. Okay, we'll just pick a term of x and we'll find derivatives of it. Okay, since yp should contain q of x, term of q of x and its derivative. We wrote the term of q of x and its derivative is 1. Likewise, we wrote the term of q of x, sin x, its derivative is cos x. Since we have, say we have some doubt whether we are getting another term other than sin x or cos x, so we'll just find the derivative of sin x, cos x, and we are confirmed that we'll get sin x and only sin x and cos x by differentiating sin x. Okay, again you can just differentiate sin x, derivative of sin x, derivative of cos x is minus sin x, minus derivative of sin x is cos x. See, you are getting sin x, cos x, sin x, cos x. You don't get any other term other than sin x or cos x while finding the derivative of sin x. Got it? Fine. Now we just simplified. We wrote the terms occur from q of x and its derivatives. X, a constant, sin x and cos x. You don't have any other term other than these 4, right? Now use this 4 and write yp. Okay, you have to write coefficient before every term. Okay, for x we'll have a, constant we'll write as b, and for sin x we'll have quotient c, and for cos x you'll have d. Okay, or you can just pick sin x and cos x first and later you can go for x and constant. Okay, or you can just write it as a sin x plus b cos x plus cx plus d, whatever. Okay, cx plus d is for x, a sin x plus b cos x for sin x. Here ax plus b for x, c sin x plus d cos x for sin x. So this is how we'll find yp using trial method. Or you can write it as yp equal to, instead of taking sin x, we can take cos x also. A cos x plus b sin x. Now for x, cx plus d. Okay, it can be any of these three. Fine. Now we got yp. The formula for yp you can say. Here A, B, C, D are undetermined questions. Now we need to find them, right? Let yp equal to ax plus b plus c sin x plus d cos x. See, at the beginning it seems hard to find yp, and with the practice you'll write yp easily by looking at q of x. Okay, so this is our yp. We have chosen yp such that it satisfies the given equation. In the given equation we are having y double dash and y power 4, right? So we need to find, since it satisfies the given equation, so we can write the given equation as, okay, here it's having yp dash, yp double dash and yp power 4. So you will find yp double dash and yp power 4. We can write the given differential equation in terms of yp since yp satisfies the equation, because we have chosen yp such that it satisfies the given equation, right? Now let's find yp dash, yp double dash, yp triple dash and yp power 4. Yp dash equal to a into derivative of x plus derivative of b plus c into derivative of sin x plus d into derivative of cos x. You can just write directly instead of writing this step. A into derivative of x is 1 plus derivative of constant is 0 plus c into derivative of sin x cos x plus d into derivative of cos x minus sin x, which gives us yp dash equal to a plus c cos x minus d sin x, right? Now coming to yp double dash equal to derivative of a 0 plus c into derivative of cos x minus sin x minus d into derivative of sin x cos x, which gives us minus c sin x minus d cos x. Now coming to yp triple dash equal to minus c into derivative of sin x cos x minus d into derivative of sin x, derivative of cos x is minus sin x, which gives us minus c cos x minus into minus plus, it's minus c, okay, minus into minus plus d sin x. Now coming to yp power 4, fourth derivative of yp. Derivative of cos x is minus sin x plus d into derivative of sin x is cos x, which gives us minus into minus plus c sin x plus d cos x. We are having yp dash, yp double dash, yp triple dash, yp power 4. Let's write all together. When yp equal to ax plus b plus c sin x plus d cos x, and yp dash, yp double dash, third derivative of yp, fourth derivative of yp will be this, right? Now 1 becomes, we'll write 1 in terms of yp since yp satisfies the given equation. Now substitute the values of yp double dash and yp power 4. Minus 2 times yp double dash is minus c sin x minus d cos x plus yp a plus c cos x minus d sin x. It's yp, right? I'm writing yp dash here, sorry. Yp is ax plus b plus c sin x plus d cos x equal to x minus sin x. Now simplify it. This gives us c sin x plus d cos x minus into minus plus 2c sin x minus into minus plus 2d cos x plus ax plus b plus c sin x plus d cos x equal to x minus sin x. So here we are having c sin x plus 2c sin x plus c sin x, which gives us c plus 2c plus c, 4c sin x. Now coming to cos x, d cos x plus 2d cos x plus d cos x gives 4d cos x. The remaining terms ax plus b equal to x minus sin x. Now just equate the equations of like terms. I'll begin with sin x. Equate the equations of sin x. 4c equal to minus 1, which gives us c equal to minus 1 by 4. Now coming to x, right, cos x. Equate the quotient of cos x. We don't have cos x term in RHS, so take it as 0, then d equal to 0. Now coming to quotient of x. Equate the quotient of x, we'll get a equal to 1. Coming to constant, b equal to, we don't have any constant term in RHS, so b equal to 0. We have a equal to, we got a equal to 1, b equal to 0, c equal to minus 1 by 4 and d equal to 0. We got the values of unknowns. Okay, here a, b, c, d are undetermined coefficients and we got the values of it. Now substitute all these values in yp. We have yp equal to ax plus b plus c sin x plus d cos x. This gives us yp equal to a 1 into x plus b 0 plus c minus 1 by 4 into sin x plus d 0 into cos x, which gives us x minus 1 by 4 into sin x. Right? Or we can write it as x minus 1 by 4 into sin x. Now we are having yp and yc. We can write the general solution. Therefore, the general solution is given by y equal to yc plus yp, then y equal to yc c1 plus c2x into e power minus x plus c3 plus c4x into e power x plus yp x minus 1 by x, sorry, it's 4 into sin x, which completes the problem. We can verify yp using yp equal to 1 by f of d into q of x. Okay, fine. Well, we have seen a problem using method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye.